In this first unit for IT Security 2, we are going to discuss attacks and malware. This is a pretty long section. We're going to discuss a lot of different terms here. So this unit is just crammed with a whole bunch of different terms for all these different attacks and all these different types of malware that are out there. So basically, it's an overview of all these different types of things. So the first thing we're going to talk about is malware. So we're going to discuss malware first, and then we're going to talk about different types of attacks. Now, one thing I want to preface all this with is that a lot of these different types of attacks and malware that they discuss in our book, especially in the attacks, when we start talking about attacks, a lot of these are pretty old. They've been around for a long time, and most software and devices basically automatically protect from a lot of this stuff. So, a lot of it is somewhat antiquated, but the more important thing to take away from all this is to see all the different ways that people have found to exploit systems. And, I think that one of the purposes of IT security is to learn from that history, to see, just how people can get through how no matter how secure we think we are, people are, especially people who are in the hacking community, are very good at finding ways to get around things. Very good at tinkering and figuring things out, which are great qualities. Don't get me wrong, but it's important to know that people can figure out their way around almost anything. So that's a big part of what this is all about, IT security. So again, take this with a grain of salt. All these different attacks and malware that we're going to discuss, a lot of this stuff has been around for a long time. So a lot of these things were discovered decades ago and are kind of unusual now. But it's important to know that they couldn't happen, they can happen, they have happened, and a lot of this stuff still does happen. So let's get started. So let's talk about malware first. So we've got a whole list of malware that's, again, this is all from our textbook. And the first one they discuss in our book is Adware. Adware is basically advertised supported software. So it's any software that's supported through advertising. Now, adware itself is not always malware. A lot of times we install software that we know is going to present us with advertising. We know what we're getting ourselves into. And usually adware refers to any software that renders advertising that generates revenue for its author. So somebody writes some software, instead of having you pay for that software, it has some advertising in it. So that's the basic definition. In application software, typically software offered in a free version, which is ad supported. So you can install software and it's ad supported software. And then typically they'll have a paid upgrade so that you can use the software without the advertisements. In software as a service or the cloud, you'll have web applications that are supported by ads. We've all used these, right? So most of the email services that we all use are ad supported if you use Gmail or Yahoo or Hotmail or any of those. Social media, for example, Facebook, that's all ad supported. So ad supported software, whether it's in the cloud or on your computer, is not inherently bad. What makes it bad is when it's, by the way, MS Office 360 is another example. What makes it malware is when it's unwanted advertisements. Advertisements that, you installed some software, or some software sometimes gets installed automatically without you even knowing it. This happens to people all the time, right? They have all these crazy pop-ups that are happening all the time that they don't know where they're coming from, and that's coming from adware. So anytime it's a nuisance, or if they're usurping certain web pages to insert their own advertising and things like that, that's when we talk about adware being malware. Probably one of the most common types of malware that most people are familiar with in the vernacular of just about everyone. If you go to somebody on the street and say, do you know what a virus is in computers? They'll say, oh, yeah, it's bad software. It's stuff that ruins your computer. So most people are aware of what viruses are. It's malicious software that infects through files. So a user has to obtain an infected file, and then the infected file is executed and then installs itself without the user's knowledge, usually. And then once infected, the virus tries to replicate itself to other files, which will then hopefully get shared downstream and get shared with other people. And it keeps infecting other pieces, other files, and on and on it goes, just like a real virus, right? So in order for you to catch a virus, you have to come in contact with someone who has that virus. It has to enter your body. It doesn't just happen automatically, right? So that's the distinction of a virus, is that it's going to, it has to infect someone by getting that file. So the user has to take some action to get a virus. It's among the most common types of malware. And again, most people know what they are. So file infector is one example. So there's macros. that can be viruses, things like from Microsoft Office, files, executables, that type of thing. And then you have boot sector viruses, which your book also discusses some things about boot sector viruses. So let's talk about worms. So what is a worm? So unlike a virus, which requires a user to spread the file, worms can spread themselves over networks on their own. So unlike a virus, which requires the user to do something, worms are programs themselves. So they're not infecting some other executable. They are themselves an executable. But one other big distinction is that where a virus, it can only infect a computer if somebody puts the file on that computer. A worm's job, or a worm, is designed to infect computers without anybody taking any action to do that. So they spread themselves. And that's what makes worms so much more dangerous, I think, than viruses, is the fact that they can spread around the network without anyone doing anything. Once a worm infects a network, and if all the computers are susceptible to whatever vulnerability that worm takes advantage of, it's going to spread throughout the entire network without anyone doing anything. One recent fascinating example, and I highly recommend taking a look at this, is Stuxnet, which is a virus from a few years ago that was developed in conjunction with the United States government and I believe it was Israel. And the idea was they wanted to take down the Iranian nuclear program. And in Iran, when they're doing the research for their nuclear program, they were using certain centrifuges in the process. So a centrifuge is a big machine that spins things really fast, right? So there's only so many companies that make those machines. So U.S. intelligence and Israeli intelligence found out exactly what model machines they were using. They got a hold of one, and they designed a worm that would be able to infect that machine and basically cause it to destroy itself. So it was beyond repair. So in the old days, if you wanted to destroy one of these centrifuges, a long time ago, a spy service would have to actually send a spy into that building and, in the dark of night and go and unplug the machine and put a bomb on it or something. But not anymore, right? Now that everything's all connected to the internet and it's a computer, they were able to make a worm that did this for them. Nobody had to even go onto Iranian soil. They just released that worm into the wild. I don't even know where they released it. It could have been in the United States. And eventually that worm made its way to Iran and brought down those centrifuges. So a really interesting example of a worm, and what you really get a sense of from that example is the fact that worms can spread without anyone knowing. It was, nobody even knew that worm existed until after the centrifuges were destroyed. So your book also discusses the SQL Slammer worm from 2003, some other worms from 2001. So worms have been around for a while, well over a decade. Like I said, a lot of this stuff we talk about, it's been around for a long time, and there are certainly new vulnerabilities out there. So worms have been around for a while. SQL Slammer worm was a great example too. I still hear about the SQL Slammer worm sometimes, which took advantage of Microsoft SQL Server. Another example malware is Spyware, similar to Adware, but it also sends information back to its creator or to someone else. So usually they employ keyloggers to do that. So a keylogger might log all your keystrokes. It might keep an eye on the websites that you're going to through some kind of website tracking. And a lot of times the spyware, what they'll do to avoid prosecution is they have some kind of confusing EULA that tricks the user, but EULA being an end user license agreement, that tricks the user into installing the application and agree to the spying. And I think most of us would never agree to this, but the EULAs, again, they kind of trick people into agreeing to this stuff, and they click OK, and then it installs the software and basically keeps track of where they're going. Why is it similar to Adware? Because a lot of times spyware is watching what you're doing to bring you targeted advertising, right? It's all about giving you advertising. If advertisers know what your interests are and the websites that you go to, they can target advertising to you that is more likely to interest you, and you're more likely to click, and they're more likely to make more money on that ad. So that's basically what spyware is. Why is it dangerous? Well, because they're seeing basically everything that we're doing on our computers when we have spyware. So we may not necessarily want people to have that data, and they could do bad things with that data, right? So spyware, they could be getting our bank account information. They could be getting our usernames and passwords to all sorts of things. So generally, we don't like that kind of stuff happening on our computers, especially without our knowledge. And again, if it's a confusing, when's the last time you read an end user license agreement? Probably never. And I remember seeing something somewhere that if you were to read every end user license agreement that you've ever clicked OK to, it would take you something like 87 years to read them all because they're so long and so intricate and all the legalese that none of us really understand. So, so spyware can be kind of dangerous, but that's another example. I think we're all familiar with the term Trojan, of course, from the wooden horse that was used to trick the defenders of Troy. They put a bunch of soldiers got inside a horse. They presented the horse to the people of Troy and said, "We have a gift for you." They pull the horse in, and then all the soldiers jump out and they take over Troy. So similar to that, users are duped into running some program that's a Trojan. So a Trojan is some program that presents itself as something useful or something that you want. They might have thought it was something fun or what have you, something like Angry Birds, right? Looks like a fun game, but really it's collecting all your information under the hood. So typically Trojans will allow a backdoor access into infected computers. So and your book talks about some methods to do that. They talk about, just at a very high level, things like back orifice and things like that. So that's what a Trojan is. So a Trojan is a program that somebody installs it. They intentionally install the program because they think that it's one thing, but really it's got some darker purpose to it. One thing that's interesting about Trojans to bear in mind is that Trojans sometimes are useful, right? Angry Birds is a great example. Angry Birds was, a fun game that everybody liked to play. It had some other purpose, right, to collect some information about you for targeted advertising. But they were able to do that by making a program that people wanted, that people found enjoyment in using. So sometimes Trojans are something people want, and even when people learn that it's a Trojan, they still like to use it. They still install it. So certainly that can happen. A rootkit is basically a virus or a worm or some kind of malware that is able to get root access. So root access is from the Unix world. It's the user that has complete control of a system. You may have learned about this in your Unix or Linux classes. So rootkits subvert, replace, or usurp core operating system functionality to provide root access for that malware. So normally malware doesn't have root access to do whatever they want. But if it's a rootkit, then they do have access. They take advantage of vulnerabilities that allow them to do things that they ordinarily wouldn't be allowed to do. So once malware has root access, they have unfettered access to the infected system. They're able to access everything. One of the famous examples they talk about in your book is the Sony BMG rootkit. So a couple of years ago, Sony is very interested in DRM, which is digital rights management. So they wanted to prevent you from being able to play or being able to copy music, right? If you had a CD, they wanted to, if you put that CD in your computer, they basically installed a program that was a rootkit that would insert itself into your operating system to prevent you from copying that CD. And it did have the effect of preventing you from copying that CD, but it also usurped some of the core operating system functionality. It got in the way of the drivers and things like that in Windows. So it was actually a rootkit, and they got into a lot of trouble for that. It was essentially malware. They made malware, and the problem is users didn't know that they were installing it. So as soon as they put that CD in the drive, it automatically installed itself, and the user had no idea that was happening. So that's one of the reasons that they got into quite a bit of trouble for that, and there was a lot of backlash. And I'm sure a lot of you are familiar with that. I'm sure most of you have heard of that attack. It's kind of funny to think of that as an attack, but really it was. It's an attack on our computers because it's malware that we're being tricked or duped into installing. So I already discussed backdoors. When we talked about Trojans, we talked about backdoors. Originally, backdoors were hard-coded access methods or passwords that programmers used to get access to systems. And you might say, gee, that sounds like a bad thing for a programmer to do. But, when you're writing some application, you want to make sure that you're able to get into it if something goes wrong. And some people used to call this a trapdoor as well. So you'll hear people call this, not just a backdoor, but you'll hear the term trapdoor. It's useful for applications that must be supported through many organizations. So for example, where I work, we wrote some applications. We write lots of applications, and we have something like a backdoor where we're able to access that application regardless of the customer that the application is on. And usually the applications are installed in secure environments, so we don't have to worry about some attacker getting direct access to it. But if somebody knew the password, knew that password that we have hard coded in the software, anyone would be able to get into that software if they had access to the machine. So, of course, we always advise our customers to have other security layers around that. But for us, once we have access to a computer, we're able to do all that stuff. But what happens when an attacker gets that password? And I don't say if they get the password, it's a matter of when. Eventually somebody's going to get that password that probably shouldn't have it. In our case with the software that we've developed, most of our customers know that top secret backdoor password to get into the software. So it's not even really a secret anymore. And it never really was a secret. It's just, usually it's the system administrators that know that. They just don't tell their end users that there's a secret password like that. So it's definitely something that a lot of people know. So more commonly, backdoors refer to programs that allow access to a system, thus compromising security. So all that stuff I just talked about, backdoors for getting into software, that's been around for a long time. That's been around probably since the early 70s when people were designing mainframe applications. I think programmers are doing that. But most of the time when we use the term backdoor in IT security today, in modern IT security, we're talking about some kind of program or some kind of malware that allows somebody to get remote access or to get into a computer remotely. So it's a little bit different than the latter definition of backdoor, but they both, and again, some people, when they say trapdoor, they're talking about what our book is referring to as a backdoor. So they'll call a trapdoor what the programmer uses to get into software, and then a backdoor, they're talking about something like back orifice, where it's a program that somebody can use to get remote access later on. A lot of times backdoors are baked into some other malware, right? So a lot of the other malware that we've already discussed will have a backdoor. That'll be one of the purposes of that malware, is to open up a backdoor so that the attacker is able to get into a system or a server anytime they want. So that's a backdoor. Let's talk about a logic bomb. So a logic bombs are malware that's designed to lie dormant until an event invokes the malicious payload. So unlike the previous malware, where it's typically installed unknowingly by someone, a logic bomb is created by somebody and installed knowingly by somebody in the background. And usually the purpose of it is to, when they install this malware, it's supposed to do something at a certain time. So, for example, let's say a disgruntled programmer knows that they might get fired in the next couple of months. Maybe they're going to get laid off. Maybe they can see it coming. They can see downsizing. So to get back at the company, they make a little logic bomb that when it detects that they're no longer working for the company, maybe it monitors the HR database or something. And once it sees a flag that he's been let go, then the logic bomb is going to go and do a bunch of damage. So that's an example of a logic bomb. And again, it's a common insider attack, a logic bomb. It's actually a pretty good book about a logic bomb. It's called The Daemon, Daemon. So I would highly recommend taking a look at that book if you like some good fiction about IT security. It's a good example for you, and it would be good practice for the term project, right? You can read that book in the style of a crime drama, but basically it's a book about a logic bomb. It's about a programmer that writes a logic bomb that when it sees his name in the obituaries, it starts launching all kinds of crazy attacks against civilization. So again, it's kind of a sci-fi. It's a little far-fetched, but it's not a bad book to read. Another example is botnets. So another type of malware would be botnets. So when we talk about bots in software, it's a bunch of programs that, or a bot is a software program performing a task under the control of another program. So another program is basically sending commands to the bot to go and do something, and usually that's remotely. In the early days, botnets were referred to IRC software used to control chat rooms. So that's where the term bots originally came from. But today, botnets almost always refer to malicious software. They can be used for stealing information, mining bitcoins, launching denial of service attacks, distributed denial of service attacks, which we're going to talk about in a little bit when we talk about attacks. So I'll review, we'll talk about some different types of attacks. And one of the ways that people launch these denial of service attacks is by getting these bots, all these little bots out into the wild. And those little bots eventually are taking commands remotely from some central server that tells them what to do. So it tells this army of bots to go and start attacking some server somewhere. And that's basically a botnet. Ransomware is software or a malware that infects a system and prevents access to files. So, and typically the user is going to be asked to pay some kind of ransom to restore access to their computer. Usually this happens through encryption. So usually what will happen is the ransomware will infect the computer. It'll find, some common files, like maybe my documents or something like that, encrypts all the files, and then it basically tells the user that they have to give them $400 or something like that to get their data back. And this happens all the time. This happened in my office one time. We had a secretary in the office that she got an email from somewhere. She thought it was legitimate. She opened up the email. She opened up the attachment because it said it was a resume or something like that. I think it was, it said this is a resume from someone. And she went to go read it, but it was really ransomware. It installed itself. It encrypted all the files on her computer. We had a bunch of files on there that we needed that weren't backed up at the time. So we had to pay, $300-400 to get the files back. And it was just the easiest way to get the files back. They usually use really strong encryption, so it's almost impossible to crack it. And as we'll learn later in the course in the last 2 units, encryption is pretty widely available. So attackers have access to this encryption. That's the same encryption that we as IT security professionals also have access to. So they can use it against us. Polymorphic malware. Let me just explain how, antivirus, we're going to talk about antivirus later in the course in about 3 weeks or 3 units. We talk about antivirus. But the way antiviruses work is they basically look for signatures that identify files that are typically viruses. So obviously the file name, names of files don't really give away what it is. It's very easy to change the name of a file. But they always have a certain signature. And again, we'll talk about these signatures later on, how that works. We'll get into a little bit more detail on that. But that's typically how antivirus identifies malware. So if malware wants to avoid that detection, it can change itself periodically. So it can morph itself a little bit, just enough to change that signature. And that's what polymorphic malware is. It's malware that's smart enough to modify itself so as to avoid detection. An armored virus, similarly. So one of the things that researchers do from these antivirus companies and in academics is they'll deconstruct malware to discover where it came from, how it works, how it communicates and spreads, all that stuff. So authors of a virus might encrypt. Again, they have access to the same complicated, strong encryption that we do. So they can use it against us. They can encrypt and obfuscate their code to prevent somebody from being able to deconstruct it. And your book even talks about how some antiviruses do that to prevent other virus authors from getting their code, so that they have to pay for it, right? They have to pay somebody to use, some portion of code. So they give you some examples of things like that. So that's what an armored virus is. So we've talked about a whole bunch of different kinds of malware. And now we're going to jump into attacks. Malware is all software or programs that are designed to do bad things, that are malicious. And now we're going to talk about different techniques people can use to attack a network. So the malware are things that you can kind of create, put in the wild, and hope to do some damage. Or you can target it to do some damage, which we'll see some examples of that later on in the course. Whereas attacks are active things that we can do. So it's a little bit more active, and it's things we can do to attack a network. So while malware is a little bit more passive, right? We create something, not we, but a virus or a malware author would create something, put it in the wild, and or use it as a tool to do attacks later on, such as things like Trojans and things like that we discussed with backdoors. An attack is an actual active attack. It's a method that someone's using to attack a network. So we're going to talk about a whole bunch of different ones. You can see them listed on the left-hand side there. And the first one we start with is a man-in-the-middle attack. So an attacker, basically a man-in-the-middle, is when the attacker inserts themselves between two parties and intercepts or modifies the communications. An example would be making yourself a Wi-Fi access point. So if I were to take my computer, make myself a Wi-Fi access point, and go into a Starbucks, and it used to be Starbucks would charge you for internet. I don't think they do anymore, but they used to. So if I paid for internet and then made myself a Wi-Fi access point that didn't cost anything, it's pretty likely that people would connect to the internet through my laptop, right? And I could put some software on there to watch what they're doing and to capture information. And I'd be willing to bet that, sitting in a Starbucks for a day doing that, you'd probably be able to get some bank account passwords and all kinds of stuff. So it wouldn't be that hard to do. And that's basically what a man-in-the-middle attack is. Many proxy servers that are used for web filtering basically employ this technique. So WebSense is a common proxy filter for internet or for the web that companies use, and it basically is a man-in-the-middle attack. And we can talk about that at some point later on. We'll probably discuss that again. But basically, how does it work? So we've got two characters down here on the bottom that want to communicate. Fred on the right-hand side wants to talk to Sally on the left. So Fred sends a connection to Sally saying, "I'd like to talk to you." She responds, and then they start communicating with each other. If the attacker gets injected in the middle of this conversation, what will happen here is Fred sends a message to Sally, but the attacker, we'll call him Mallory, in the middle, intercepts that communication, and then he sends the request to Sally. And then Sally thinks she's responding to Fred, but really it's the attacker who reads the message and then forwards it off to Fred, and then so forth and so on. So the attacker is basically reading all of these messages, and that's just a simple example of a man in the middle, somebody inserting themselves into the middle of the communication. Lots of different ways to do that. We'll talk about some of that later on. So a denial of service attack, it's an attempt to make a network service unavailable. The way I always think about denial of service attack is a Chinese restaurant. Just about every Chinese restaurant I've ever done business with around my house, about 95% of their business comes through the phone, right? So they all seem to have, 3 or 4 telephones. And, if they're using one phone, then the call rings over to the second phone and the third phone. They're usually not that sophisticated. They just have, oh, look at that. I'm talking about malware, and my anti-malware program wants to install an update, so I'm going to say later. So usually what will happen is somebody will make a phone call to the Chinese restaurant, and it rolls over to the next phone. Thing is, if the Chinese restaurant didn't have phones, if their phones weren't working, they don't get any business, right? Or at least 95% of their business is going to be gone if you can't get to their phones. So if you were upset about some poor service at the local Chinese restaurant, you could get 5 or 6 of your friends together, and everybody could just keep calling that Chinese restaurant all day long, over and over and over again, so that when real customers try to call, they get a busy signal. And that would be like a denial of service attack. So you're trying to make something unavailable. Lots of different ways you can do this. You can consume resources. You can disrupt configuration information. You can disrupt the state, example in TCP. You can disrupt the established connections. You can disrupt the physical network components themselves. So these are just 4 basic techniques for doing denial of service. Denial of service isn't always, most people when they think of denial of service, they think of a DDoS attack, which is a distributed denial of service attack, which is certainly one really good example of a denial of service attack. It's one subset of that. And that would be, I guess, would fall under consumption of resources. But even just unplugging an Ethernet cable from the router, that technically is a denial of service attack. You're making it impossible for people to use the network. So lots of different examples. In your book, I think they talk about some of these things. An ICMP flood, which is known as a Smurf attack. We'll talk about that in a minute or two. A SYN flood, where you just send a whole bunch of SYN packets. And again, some of this requires a little bit of background knowledge on TCP, which is beyond the scope of this course, but you can certainly look at how that works. A teardrop attack is another example, and flashing, which is where you flash the firmware on routers and switches using some protocols like SNMP and things like that. And that makes the device, basically, you're bricking the device so that nobody can use it, which, again, is a denial of service. So those are some examples of denial of service that you could look into. Your book talks about a replay attack, which is when you're listening to known valid traffic, and then you're using that traffic to masquerade as the previous valid transaction. One of the classic examples of this that they talk about is a bank transaction, right? If you watch a transaction on the network of somebody depositing money into a bank account, you capture all those packets, and then you just replay them. The thought is maybe you can deposit more money into that account erroneously. Of course, the reality is it's a lot more complicated than that, right? But the theory is there. right? That you should be able to replay those packets. And if somebody had a poorly designed application, you could certainly do that. You could use a replay technique. And replay is, again, very similar to man in the middle. A lot of times man in the middle attacks rely on some replay techniques. What is spoofing? So let's talk about spoofing. It's a technique used in many of the aforementioned attacks I talk about, and even some of the ones that we're going to talk about. Spoofing is when you're masquerading as someone else. You're pretending to be someone else. So you're using techniques to fool systems into thinking that illegitimate traffic is legitimate traffic on the network. It's used a lot in email, where you can spoof an email address. You can spoof an IP address. It's used in a Smurf attack, which we just talked about a few minutes ago. You can use it to mess with TCP sequence numbers, to spoof packets or inject packets into a TCP session and usurp some of those packets. So let's take a look at a really basic example. In networking, you've got routers, and then you might have nodes that are connected to that router. And typically, if I've got a packet that is on device number 1 that wants to send device number 2, the packet's going to have a source address of 1 and a destination address of 2. It's going to get sent to the router. The router is going to see that the source is 1 and the destination is 2. It's going to know to send that packet to device number 2. Now, let's say my attacker out on the internet sends a packet. His source address is somewhere on the internet. That's an I there, not a number 1. Sorry about the ambiguousness there. But he might set the source address is obviously going to be an internet address, but the destination is going to be number 2. And the router is going to be smart enough to look at that packet and say, wait a minute, I'm not allowed to send traffic to device 2 when it comes from the internet, so it's going to discard the packet. But then the attacker might get smart, and he says, well, I know that there's a number 1 inside that network, so I'm going to make my source address a number 1 and destination number 2, thinking that that router is just going to pass that traffic to number 2. So that's an example of spoofing. And again, it's a lot more complicated than that in the real world, but that's the basic theory. And a Smurf attack is basically when you've got a whole bunch of computers out there that all are running maybe a bot, right? So it could be a botnet, and they're all sending packets spoofed with a spoofed return address to someone else. So they might send a return address that's going to go to some other system somewhere, and all those SYN packets will attack that one system, and that's basically a Smurf attack, and a variation of that is a Fraggle attack. I have no idea where they come up with these crazy names, but again, that would be a Smurf attack or a Fraggle attack. So let's talk about some email stuff. Spam. We all know what spam is. Other than delicious canned meat, spam is unwanted email. It's advertising and things that we don't want. And we always see these statistics running around the internet about how spam is some absurd percentage of traffic on the internet. I remember seeing it one time. They said it was something like 87% of all emails were spam. And judging from my unfiltered inbox, if you go and look in my spam box, there sure is a lot of spam in there. So there may be some truth to that. But I think we all know what spam is. Other than delicious meat from Hormel Foods, it's certainly something that we want to get rid of for the most part. Spim is the same thing, but for IM. So most of us use IM now, or instant messaging or chat. Facebook has chat baked into it now, so a lot of people use that. AOL Instant Messenger, Yahoo Messenger, Google Chat, and things like that. So now we're starting to see spam in chat services, where all of a sudden you get a chat message pops up, and you request, you accept the friend request, and then all of a sudden it's advertising. Or even worse, it's like some kind of a chat line or something trying to convince you to go and chat with some woman somewhere or something like that. So, and a lot of times they're just robots. They're just bots that are trying to communicate with you. So that's spam, and that's becoming more popular. Phishing is basically where you're sending out emails asking for some information from people and hoping that they're going to respond with some personal information. I don't know about you, but if somebody sends me an unsolicited email asking for my bank account information, I'm probably not going to send it back. But you figure if you send that to millions upon millions of people, if only 1 or 2 of them are foolish enough to send their bank account information, then you've got some pretty valuable information. And how long does it take to send a couple million emails? Not that long, right? So you can send hundreds of millions of emails relatively easily with the right software and all that stuff. And if you do it before people start blacklisting you, you can get some pretty valuable information. So that's an example of phishing. Now, if you don't want to send hundreds of millions of emails, you could do spear phishing, which is where you know who you want the information from, you have a specific target in mind, and you send emails to that target maliciously trying to get that information. And spear phishing really crosses the line into social engineering, which we talk about in the next unit. We're going to discuss social engineering, but that's basically spear phishing. And the other example is vishing, which is voice over IP phishing, where nowadays telephone calls are so cheap. I mean, almost to the point of being free, that you can you can basically spam over the phone now. And you can just call people and try to get their credit card numbers. And I don't know if you guys have experienced this, but I get these calls periodically where I get a phone call saying, "Good news, you're eligible to lower your credit card interest rate, +1 to continue." And you press 1, and then some operator gets on the phone and says, "I just need your credit card number, and I can go ahead and lower your interest rate." Well, clearly they're just trying to steal your credit card number. So the best thing to do is just hang up, or if you're really feeling like you want to mess with somebody, you can mess around with them a little bit. I like to pretend like I'm looking for my credit card for a while and waste their time, so there's one less person that they're trying to scam. And then they ask me for my credit card number, and I'll say, "Yeah, I've got my card number right here. It's an ace of spades," or something like that. So that's basically what vishing is, and that's, again, kind of something new that's cropped up in the last couple of years. We've got some various protocol types of attacks that you can use. So basically, and I grouped all these different attacks your book talks about. I call them protocol attacks, which is my term, by the way. Who knows? Maybe that'll become a real term one day. But basically, you're using different protocols, or the properties and attributes of different protocols to attack networks. And what I have on my screen here on the lower right-hand corner is basically what a TCP packet looks like. I'm sorry, a TCP segment. So in networking, you've got the application layer. In TCP/IP, you've got the application layer, then your transport, network, data link, and physical layers. You got 5 layers. And at layer 4 is our transport layer. You've got TCP, then you've got IP at network, and then you've got data link the data link layer, and then your physical layer. At the transport layer, we use segments, which is where we get our port numbers from, and our sequence numbers and acknowledgement numbers. Those sequence numbers and acknowledgement numbers are used to maintain state between connections, and that's that 3-way handshake that you learn about in your networking classes. Again, a little bit out of scope for this course, but one of the attacks they talk about in your book is the Christmas tree attack. By the way, it's attack, not attach. Sorry about the typo there. Another one, and I think they also refer to in your book as a lamp test. I've always heard that called a lamp test, but it's basically taking advantage of some properties in the protocol to attack a network. So, and TCP/IP hijacking, which I sort of told you about before, is another example of a protocol attack. So let's talk about TCP/IP hijacking first. You've got a sequence number and an acknowledgement number in that segment header for TCP at the transport layer. And those sequence numbers basically are how systems put these packets together. And in theory, you could hijack a connection if you hijack those sequence numbers and acknowledgement numbers. Again, it gets a little deep with TCP. I don't want to explain how TCP works, but just if you want to backfill your knowledge a little bit, you can go read, I guess it's RFC 793, I think, to look at how TCP/IP works. By the way, don't be afraid to read the RFC. It's not that long, and it's pretty descriptive. You'll get a good understanding of TCP. But basically, if you can inject your own sequence numbers and acknowledgement numbers that fit in line with what the reality is, then you can hijack that connection. And the other example, a Christmas tree attack or a lamp test, down at the bottom, you can see we've got some various flags. And there are, let's see, 8, 9 different flags in TCP, I think. So one of them would be the SYN flag, which I just highlighted in green. Another type of flag would be the push flag and the reset flag. If you set all 3 of those flags should never be set at the same time. And there was a bug, I think, in Microsoft Windows years ago that if you set those 3 flags, it would crash the TCP/IP stack in Windows. So you could crash a machine by simply sending a packet with those 3 flags turned on, which seems kind of silly, but it worked. And then you could just set all of the flags, and it would crash some systems and cause all kinds of problems on the network. And because they're all lit up, all those tags are turned on. That's basically our Christmas tree, right? So that's where the term Christmas tree attack comes from, or lamp test. In our book, they really don't get into a lot of detail on these protocol attacks, which is why I'm explaining it in a little bit more detail here, because we're not going to get into that in any more detail later on. Though you may have talked about this a little bit in IT Security 1. So most of the other attacks that we've talked about, we are going to expand on those a little bit later on. So that's an example of a LAMP test. So again, there's a bunch of different protocols that you can take advantage of to attack networks. Pharming is another example. It's directing users to fake websites. We'll talk a little bit more about that with squatting. Privilege attacks are using various techniques for the attacker to elevate their privileges, very similar to a rootkit, right? So you would use a rootkit to do a privilege attack because it's going to elevate your privileges. There are lots of different ways to do that, to elevate your privilege. In the Unix world, you can use setid commands to get root user privileges, and there's different ways to do that. And you can sometimes do that through other programs. So some programs have the ability to run as root for certain functionality, and you can take advantage of that and then kind of inject things into that to get the root functionality. So lots of techniques to elevate your privilege, and anytime you're using those techniques, that's a privilege attack. A lot of attacks are from insiders, right? So much of our discussion so far, we've talked about outsiders, with the exception of the logic bomb, right? The logic bomb, I talked about how a lot of times that's an insider. Usually a logic bomb is an insider type of attack. But all of the attacks that we've talked about can all happen from the inside. It could be somebody who works for the organization that's using some of these techniques to attack the network or to attack workstations and try to get information. So attacks can certainly come from the inside. Our book also talks about poisoning. So poisoning is, and there's two basic types of poisoning to talk about in our book, but they're talking about cache poisoning. So what is caching? Caching is to speed things up for efficiency. A lot of times we cache information. So caching is pretty important in modern networking. We use caching a lot to make sure that things are running quick, that things are a lot faster. But one of the problems with caching is you can poison a cache. You can put false information into the cache, and then machines don't know, the software doesn't know that that's fake information. So one example that our book talks about is DNS caching. They actually have a pretty good write-up about it. Most of the stuff they talk about in the book is very, very short, but the DNS caching, I'm looking in the book right now, they've got probably 7 or 8 paragraphs with screenshots and everything. So you can get a pretty good idea of how DNS caching or DNS poisoning works by looking in the textbook, but I'll give you a brief example. Basically, you compromise DNS so that when somebody asks for an IP address from a host name, they're getting the wrong IP address and they're getting sent to some other server somewhere. And that's a powerful tool if you're an attacker, because you can redirect people to your server to then give them more malware or to spy on their traffic or what have you. All kinds of things you can do if people are getting directed to your IP address instead of the reality. Now, that's something you might do on the internet, DNS poisoning. ARP poisoning is something more common on a local area network. One of the sort of challenges for an attacker on local area networks, back in the old days, we had hubs, right? So on a hub, if you plugged into a hub, you can listen to all the traffic on the network. It doesn't work anymore because now we all have switches, so you can't just listen to all that traffic. But what you could do is you could poison the ARP cache. And ARP cache is basically in the switch. The ARP cache is how the switch knows which IP addresses belong to which MAC addresses. So when a system is talking to another machine on the LAN, it's not really using the IP address. You're really using the MAC address. You're saying to the switch, "I'd like you to deliver this traffic to this physical address, this MAC address, also connected to the switch." Well, you could poison the switch into thinking that that MAC address for your target is actually you, not the intended recipient. So that's a basic example of ARP poisoning. And sometimes ARP kind of poisons itself. I think most of us who work in networking have experienced that, where the ARP tables get corrupt and you have to reboot and usually to fix an ARP problem, you just reboot the switch or the router and the ARP tables are cleared. You can even do that with commands usually. But that's almost a denial of service, right? Because the fact that you have to reboot that device and nobody can access the network for a period of time, there's a little bit of denial of service. So that's some poisoning techniques. There's a whole bunch of different client-side techniques that your book, and I consolidated these client-side attacks. Actually, there's only 2 of them in your book. Now I'm looking, but so there's a few different attacks for client-side. So many applications are web-based. So there's all kinds of things that we can do over the web to attack. And the problem is, in order to access the web, you're using a web browser. So web browsers have become a new way for people to access our networks. So it's a new attack vector, the web browser. So there's various things that we can do with web browsers. One of those is injection attacks. So there's 3 types of injection attacks, which we're going to talk about in much more detail in the next unit. So in the next unit, we're going to talk about different types of injections. But the 3 basic types that we're going to talk about are SQL, XML, and LDAP. And basically, just to give you an example, if I'm using a web form, if I'm going to log into a website, I might provide a username and a password, and this would be the SQL statement. So hopefully most of you have taken some database classes and have learned about how databases work, and you know that this is a basic select statement where you're saying, show me any record where the username is Bob and the user password is secret with the 3s instead of the E's, which, by the way, is not very secure. We'll learn about that in just a few minutes. So that might be one example of a SQL injection. How would this work? Well, if you think about it, how could I make that SQL statement more ambiguous? I could say, or 1 equals 1, right? So if my SQL statement looked like this rather than like this, right? So if it's Bob and secret, I'm going to get 1 record if there's a Bob with the password of secret. But if I tack a or 1 equals 1 on the end, then it can be Bob and secret or 1 equals 1. And if you do order of operations, it's always going to return all the records because 1 is always going to equal 1. So this might be a way to get around the login on a very poorly designed. By the way, it'd have to be a really poorly designed web application for this to work. And we'll talk about how to mitigate these types of attacks later on. But this is just a really simple example of how you can inject some SQL. So when I'm filling out the form to log in, instead of putting Bob for my username and secret for my password, I would put in for the password that whole thing I have underlined. So I would add at the end of some fake password, I would add a quotation mark to end the previous statement or to end that variable, and then I would put or 1 equals 1. And then I missed a step here, I would probably put a semicolon on the end so that that last quotation mark would get ignored by the SQL engine. And again, this is something that most applications should be able to protect from. Most modern applications, but classic example of a SQL injection attack. And again, we'll talk more about these injection attacks later on, so we'll get into this in a little bit more detail. Another example for web browsers and web clients is header manipulation. So when whenever user input can include line feeds and carriage returns, it can allow the attacker to change the header, to manipulate the header. And that can allow things like cross-user defacement, cache poisoning, which we've talked about already, cross-site scripting, page hijacking, all kinds of crazy attacks can happen when you can manipulate the header. When you manipulate the header, you can pass anything you want to the web server. You can use it to do all kinds of attacks against Apache or IIS or something like that. Again, we're going to talk about header manipulation in a little bit more detail later on. So we'll talk about this a little bit more. You don't have to worry too much about it now. But for now, there is about 2 sentences in this chapter that describes header manipulation. So at least give you a little taste of it. And again, we'll talk about this later on. As far as, this should be its own section. It should not be client-side, but got a little typo here. So password attacks is another class of attacks that your book talks about. On page 226, there's a whole, probably 4, maybe 2 pages or so, maybe 3 pages that talks about different types of password attacks. And I'll talk about each one of them very briefly, but the first thing they talk about is poor password choice. If you choose a bad password, then it's going to be very easy for somebody to take advantage of you and guess your password, right? So if you use your, the name of your dog and everybody knows your dog's name, they could try that for your password and then get access to your account. So that's one example. A dictionary attack is when someone takes a dictionary and uses that to try every possible word in the dictionary for your password. So if you use real words for your password, it's going to be pretty easy for somebody to try all those words to attack and get your password. One thing I should tell you before I continue on, that in most cases when people are trying to crack passwords, they're not sitting in front of a web form and trying one password after another to try to gain access to your account, right? Although they could, right? They could do that. And certainly there are attacks that work that way. But the other method somebody can get your password is if they have the hash for your password. So if your password is stored as a hash, what they're going to do is try to use that same hash mechanism or hash algorithm to find a matching hash. And once they have a word that hashes to the same thing as your password hash, they now know what your password is. Hopefully, you're a little bit familiar with what hashes are. We'll talk about hashes later on when we talk about cryptography. But for right now, just understand that when you take a pattern of characters, you can create a hash from that. And that hash is how they store your password, obviously. That way it's not stored in a way somebody could just read your password. But the only way to crack that is to try different words to try to get to that hash. So one way you could do that is with a dictionary attack, where you keep trying different words until you arrive at the same hash. The other method you could use is brute force. So where a dictionary attack relies on dictionary words, brute force basically tries every possible combination of letters, numbers, and characters. Problem with brute force is that it could take a really long time, right? So if you've got a really complicated password, so if a dictionary attack doesn't work because your password is not a dictionary word, and dictionary attacks, by the way, are pretty quick. You could do a dictionary attack nowadays on modern hardware pretty fast, especially if you do it on, in the cloud with Amazon or something like that. But a brute force takes significantly longer because, if you think about it, if the password can be up to 32 characters or something, and it can be letters, numbers, and symbols, that's a lot of different characters. That's, zillions and zillions, some astronomical number of possible combinations. So it does take a long time to use brute force. So sometimes they do a hybrid, which is a combination of dictionary and brute force, where you're using dictionary words, but you're combining them in different ways. You're substituting letters and numbers. So, for example, threes are becoming, E's might become the letter 3, so it would crack that secret password I showed you earlier, things like that. So you might use a hybrid method to do that. The birthday attack's a little bit more complicated. I'll summarize it like this, the birthday attack. Your book talks about the birthday attack, but it doesn't really explain what it is. They give you a complicated little math equation in there, but they don't really explain what it means. The idea is that, let's say I had a document and I get the hash code of that document. Let's say it's a contract. It's a legal contract, this document. And you make a hash code of that so you know that it's the right document. It has some integrity, right? See, that's the I in CIA, which you learned last semester. So if I were to change subtle things in that document, maybe I could start changing lots of things in that document until, but each time I do that, that hash code is going to change. But mathematically, there is a possibility that if I have X number of documents, that 2 of them are going to have the same hash code. That's the basic concept here. And then I could take that second copy that has the same hash code and present it as if it's the first copy. So even though it's not the same contract, it has the same hash code, and the recipient would have no way of knowing that it was altered. And the reason they call it the birthday attack is that there's this mathematical principle that if you asked 30 people in a room when their birthday is, the odds that 2 people would have the same birthday, most people think, logically, they think, well, the odds are going to be pretty low that 2 people are going to have the same birthday in a room of 30 people, when in fact, the odds are about 70%. So with 30 people in a room, you've got 70% odds that 2 people are going to have the same birthday. So the odds are really not that astronomical. Now, I'll temper all this by telling you that with modern hashing algorithms like SHA-3 and things like that, it really is almost astronomical to have 2 hash codes that are the same for 2 different things. But that's the idea here. That's the concept with a birthday attack. It's kind of abstract on how to apply that to password attacks, so I don't want to get into that too much yet. And I don't know if we really are going to get into that in too much detail in this class, but certainly if you take a cryptography class, they'll talk about this birthday concept, and you'll learn more about the math behind that later on. And the final method, which is probably the most common method, is a rainbow table, where you take... so the problem with a brute force attack or a dictionary attack is you have to convert all of those words and all of that stuff that you're doing. You have to convert all that into a hash before you can compare it to the hash in the file that you're trying to crack the password of. And that all takes computational time. But what if instead of having a dictionary, instead you just had a list of a whole bunch of known hash codes? And instead of doing brute force, you have a list of all the known hash codes for a brute force attack. Because you know what they're going to be. You start at 0 and work your way up. You can kind of predict what your brute force is going to look like. So you take all the most common stuff and you develop this rainbow table. You develop a table of all these possible hash codes. And first, you check to see if there's a match on one of those existing hash codes. That's a rainbow table. So again, that's probably the most efficient way to crack passwords. And There's lots of tools out there that do that. In fact, most modern password cracking tools do all of this stuff. They take advantage of all these different techniques. All right, we're almost done. We're in the home stretch here. We've got 2 more topics to cover. We've got squatting and watering holes. So typo squatting or URL hijacking, that's the idea that you can use misspellings to masquerade as a legitimate website. I'm sure some of you have been a victim of this. If you type, like GOGLE or something instead of Google, or if you type, you mistype Facebook, FACBOOK or something like that, then you're going to land on the wrong web page. One of my favorite examples is if you type Southwest Airlines instead of Southwest Airlines, you'll land on a web page of complaints about Southwest Airlines. So that's an example, I guess, of typo squatting, although I believe that the courts have ruled that they have a right to do that. It's freedom of speech, right? So they can have a fake website for Southwest and talk about how much they hate Southwest. But that's basically an example of masquerading. So people can do this with malicious intent as well, right? So if I register the domain name chase.com, but Chase spelled CHACE instead of SE, somebody might misspell it and land on my webpage. And then I make my webpage look just like the Chase Bank webpage, hoping that somebody's going to try to log into their bank account. And then I've got their username and password for their bank account, and I can steal all their money. So that's an example of how you would hijack a URL to do bad stuff. And I'm sure all of you have probably landed on websites at some point in your life that you didn't intend to because you misspelled it. And again, it's pretty common. So last example in our book, and I was trying to look for an example of a watering hole attack, but I had a hard time finding a good one for you. But basically, a watering hole is where the attacker plants malware at a specific website and waits for the users to get infected. So the idea here is that you can target specific types of people or target specific users with a watering hole attack. I'm not so sure how common they are. I think you have to have a lot of resources to initiate something like a watering hole attack. Why is it called a watering hole attack? Basically, the idea is if you're a hunter, you can stake out a spot near the watering hole, wait for the animals to come and drink water. Eventually, all the animals have to drink water. So if you're at the local watering hole, all the animals are going to show up at some point, and you can start picking off different animals. So that's the idea behind a watering hole attack. So in a watering hole attack digitally, we're basically going to a place that we know all the people that we want to attack are going to go to at some point, and we use that as our launching pad to infect those users. Okay, so there we go. It's almost an hour. We got 3 minutes short of an hour. So we've talked about a whole bunch of different types of malware, and then we talked about a bunch of different types of attacks. There was a little bit of overlap between the two. I was very brief on a lot of these because we're going to expand on some of these later on. So in the next unit, we do expand on a few of these, and then so forth. Even a couple units even beyond that, we come back to some of these methods. But this is an important unit. It's important to make sure you understand all this stuff because number one, we're going to be talking about it again in this unit or in the first part of this course. And number two, you're going to want to use a lot of these in your term project when you talk about different types of attacks. So if you have any questions, please let us know, and thank you for watching.